Answer?
Negative sign.
If you're not sure, you can always check. The derivative of sine of stuff is cosine of stuff times the stuff. There would be times minus 1, yeah? That's what this minus is there to fix. But your answer is supposed to be positive. Say that makes sense.
That makes sense.
Remember, integration is the anti-derivative. It's the undoing derivative, the opposite derivative. Evaluate it from 0 to just finish this question. Again, I'm urging you to factor out the minus. You're going to have an answer minus an answer. Plugging in pi over 2, and then plugging in 0. Okay, Joshi, what's this one?
That's sine of pi over 2, which is 1.
It is minus.
What do you mean? Just 1 and then the next term.
Sorry. Minus
0.
what?
That's the sine of pi.
Exactly. So your answer is?
Negative 1.
Negative.
Why do you have a negative outside the big one?
That's this negative. I just copied it. Minus.
Do you have to do that? Or it's just something?
Yes, you should do that. If it was 2, I would have factored out 2. Whatever is not variable part, I will always write factor in. If you recall, from probably our very last lesson, we were doing area, is the integral from a to b of f of x dx. We determined that, we went through the whole derivation of why it's like. And by the mean value theorem, if you recall, just make a diagram again, if it was something like this from A to B, we said there had to be a C such that the area under the curve, which is this integral, is equal to f of C, that would be the height of the rectangle, times the base. What's the base?
Minus
Okay. So, let me just write that here. I'd like to go through the process now of actually trying to find that value. Up to now I said there has to be a value, but let's see if we can find out what that value C is. So, the book again doesn't use C. The book in that place there uses X star. So when you see it, that's what it is. Here's our example, really easy example. F of x is x squared on the interval 1 to 4. So we're looking at that picture. What's the diagram of? Opens, turning point is. Sketch it quickly, please. So we're interested from 1 to 4. There is an area, a well-defined area, under the curve from 1 to 4. Guess. Is C halfway? 2.5, I guess, is halfway. Here's our rectangle. I mean, my diagram is not perfect, but the answer is
No.
2 words.
No.
So it's hex probably no. We don't know where it is, but probably not necessarily us to try to find it. Now, we're looking at this, rather, as our integral for area. So we'll integrate from, good. The function which is x. And on the right side of the equation is f of c, I don't know what that's going to be, times b minus a. I think you could figure out what b minus a is.
3.
Anyone not sure where we're getting 3 from? So if this is a definite integral, it's a number. It's not x, this is a number. So integrate and evaluate, please, and let's get that number, please. Shouldn't need your calculator for this. Just getting x to the third over 3, 1 to 4. You should know 4 cubed. So you have 64 cubed, thirds minus 1/3, which is, and 63 thirds is actually, so this became 21, and that's equal to f of c times 3. So f of c must be
7.
at the end. So let me find a place to start. So f of c is 7, but I want to find c. How can I find c? F, what's f of 1, what's f of 2, what's f of stuff, what's f of c? What's f of 1, what's f of c? So what's c? So it was plus or minus, but they're both not in our integral. What's the answer in the integral? We just want to be sure that square root of 7 actually is a number between 1 and 4. We didn't mess up, is it?
Yeah.
So we actually have the ability to find, not only to say it exists, but we actually can find it, and that would be the process. How many understood what we just did? So the f of c, and it happened at, when c was the square root, but I mean, somebody get it in there as 10th, square root of 7. I don't know.
2.6.
So, just want to put this here. Just roughly, it's around here. And f of c is actually a y value. We can kind of look at that f of c as the average of all the y values. Does that make sense to you? It's an average of all those rectangular strips are infinitely thin. It's an average of all. It's not the biggest, it's not the smallest, but it is an average of them. I'm going to use that other board there and go through a little derivation process. Turning. Hi, Ruthie. I'm calling her. That's why I said hi.
7 times the square root.
Pardon me?
So 7 times the square root of 7 would just be its area, right?
Where are you getting 7 times square root of 7 from?
Base time. Oh no, wait. C is its.
Oh, wait.
No.
Say it.
Yeah.
On camera.
Yeah. So C.
Base times height, yes.
So F of C is the height, right? So you,
But square root of 7 isn't f of c. F of c turned out to be 7,
so you do 7.
and the base
7 times 3.
is 21. Usually it is anyway. Average
It's ruined my street. I didn't put it so long.
It's true. You were on the street. Keyword is you were on the street. We all know this, yeah?
Yeah.
I'm going to go through some familiar stuff with you. I want want to solve this equation for 1 over n. Can you tell me what 1 over n equals?
Delta x.
Little algebra, come on.
Delta x minus n.
Just a little algebra. Yeah? Exchanging
Means.
means. There's a 1, there's an n.
50-50 chance.
So this expression represents the average of the y's. We read it as y average, say that.
Y average.
See, if you were taking an average of the y values and they were a finite number, you say y1 plus y2 plus y3, yeah?
Yes.
Let's say we have n of them plus yn, and what would you have to divide by to get an average of all the y values?
N.
Does that make sense?
That makes sense.
That numerator, I'm just going through a process here, maybe I'll just write it. Could be seen as f of x of 1, as f of x of 2, instead of y's, plus 3, x of 3, plus f of x of n. And again, it's over n. Yes?
Yeah.
I'd like to take this over n and actually see it as if it was multiplied by 1 over n. Is that okay? Isn't that exactly the same? Were there algebraically? Anyone know why I wrote it this way?
Substitute.
Heck yeah. So we actually have an expression for that 1 over n, and it's that.
Yeah.
So I'm going to take away that, remove it, and replace 1 over n with a delta x in the numerator and a b minus a in the denominator. I'll write it again for you. So the b minus a, delta x represents that 1 over n that we just had. That's what I'm going to do. I'm not going to stop here. I'm going to go straight through here, but we're going to end early. Anybody have a problem with that?
No.
Good. So f of x1 and x2 and x3 could be more simply written as the sum of x of k's as k goes from 1 till there's b minus a in the denominator. If you don't mind, I'd like to write as 1 over b minus a times sigma. I just want to make it a little higher. Say there. Still, this in the numerator, the sigma's in the numerator, the delta x is still in the numerator, and the b minus a essentially is still in the denominator, just written in a different form. Ready? Yeah? So, if I wanted not the sum of 10 y's, or 100 y's, or 1,000 y's, but really the average of all the y's, what would n have to be doing? Yes. So, I'm going to take a limit as n approaches infinity of this whole thing. And if you take the limit as n approaches infinity of this sum, just write it over here so maybe you'll see it better. We actually have an expression for this part of it. Just have to, for you to recognize it, I have to say, all right, as n goes to infinity, what happens to delta x?
Small.
What happens to delta x?
Tends towards 0.
Yes. That limit as delta x approaches 0 of sigma f of x d delta x is actually replaced with what? This is the first fundamental theorem of calculus. First we learned it as Riemann sum, and then we learned it by that other